Only mode.
Hello, good afternoon, everyone. My name is Fadi Saad. I'm co-founder of MassRobotics and vice president for strategic partnerships. MassRobotics is the first and the largest robotics startup escalator in the US with a particular focus on commercializing robotics, AI, connected devices technologies. Right now, we're leading a cluster of around 350 robotics companies on the East Coast. We have more than 55 startups as residents in our 40,000 square feet of office and shared lab space. We also have more than 40 corporate partners, amazing companies like Amazon Robotics, Mitsubishi Electric, Analog Devices, General Motors, FedEx, and much more others. So welcome to our next signature event, Robotics in Construction. This is one of our series events where we deep dive into a particular vertical, and today we will deep dive into robotics, and we're looking at what are the challenges in construction, what are the opportunities and innovation that some of the startups are working on. So just a little bit of context about this whole initiative around robotics construction. 2 years ago, Rick Rundle, the one who's leading Autodesk Technology Centers, and I were having lunch just across the street in the Dry Dock Cafe. And we were chatting about the partnership between MassRobotics and Autodesk and what we can do to help our respective communities. We both realized that the intersection between robotics and AEC, architecture, engineering, and construction, will grow dramatically in the coming few years. And we decided to do more work to lead this particular vertical. Through our collaboration, we decided to have the first ever Robotics and Construction Summit back in 2018. Today, this is the second version of this event. And as McKinsey reported, construction is one of the largest sectors of the global economy. And almost $10 trillion every year is spent on construction-related goods and services. However, productivity in the U.S. Construction industry has been almost the same since 1945. Just in comparison, productivity in other industries like manufacturing, retail, and agriculture grown more than 1,500% over the last few years. So this constitutes amazing opportunities for robotics AI technologies. Adding to that, that as we all know, construction is an industry that has been suffering of shortage of labor over the last few years. So again, there is a tremendous opportunity to work together and see how we can generate huge value. So we have a great lineup today. We will hear both from construction companies about their needs, how they see the future, what's important to them, and also the barriers they see to adoption. And we also hear from startups and innovative companies pursuing technologies to help solve some of these challenges. So before we begin the presentation, a few housekeeping items. This session is being recorded. We will not be sharing the slides, but you'll be able to review and share the recording with colleagues after the webinar. Due to the number of presentations and amount of content that we're bringing to you today, we will not be taking questions live. We will be monitoring the questions tab in the control panel on the right of your screen. We will forward all the questions to the participating parties and allow them to answer you directly. I would like to thank Autodesk for their collaboration on this event and their continued support as a strategic partner for MassRobotics. Before I turn it over to our keynote, we will show you a video highlighting some of Autodesk technologies. And for best viewing of this video, please close your other application currently open your computer. Sometimes the video pop up behind other application. So now to this video.
Let's go.
All right. I hope everybody can hear you.
I hope everybody can hear you.
Yeah, now it's my pleasure to introduce Jim Lynch. Jim is a close friend, and he's the Vice President General Manager of Autodesk Construction Solution. He will be giving us a look at the future and what construction site might look like. Jim comes to us from the West Coast. So good morning, Jim.
Actually, I'm on the East Coast.
I'm on the East Coast.
Oh, okay. Good afternoon, then.
Well, thank you,
Jim,
Fatty.
please, the floor is yours.
Thank you, Fatty. I'm really excited to be here today to share our view of the future of construction. You know, and certainly the partnership between Autodesk and MassRobotics is important to all of us at Autodesk. I'm Jim Lynch. I'm the Vice President and General Manager of Autodesk Construction Solutions. I've been with Autodesk for more than 20 years, spending the early part of my career in the manufacturing side of our business and then the last 20 in the AEC side. So Autodesk's vision is to help people imagine, design, and make a better world. And hopefully you saw that in the video that we just showed you. We make software for people who make things. So if you've ever driven a high-performance sports car, admired a towering skyscraper, used the smartphone, watched the great film, chances are you've experienced what millions of Autodesk customers are doing with our software every day. So at Autodesk, I speak with customers on a daily basis, really, and get a chance to talk to them about their challenges and opportunities. So today I want to share with you 3 technology trends that we're seeing that are really shaping construction, the global construction industry. But before I get to those trends, I do want to give some context around what we're seeing happening in the construction space today. And Fatty actually talked about some of these things, and he is spot on. So let me hit some of these things first. First of all, I think we all know this, that by 2050, there will be 2 billion more people on the planet. So to support this population explosion, we must build essentially 13,000 structures every day for the next 32 years. Yet construction continues to be one of the least productive industries globally. Production methods have essentially remained unchanged, and they're marked by a lack of repeatability and predictability. You heard Fatty say there is a shortage of skilled labor. In fact, according to McKinsey, about 41% of the current US construction workforce is expected to retire by 2031. And poor risk management is leading to costly rework and budget and schedule overruns. Second trend that I want to talk about is investment in M&A in construction and construction technology in particular. This has seen accelerated growth. We've seen a rise in venture capital firms investing in startups and incumbent players making new bets. This is, of course, accelerating disruption of some of the current construction business models. Finally, while construction has traditionally been a laggard in terms of technology adoption, this past decade has seen a growing demand for technology in construction. And of course, mobile and cloud computing is enabling project teams to get technology out of the office to the job site, resulting in increased adoption. While none of this should come as a surprise, the COVID-19 pandemic has absolutely accelerated future innovations. In fact, in a recent survey, 400 construction executives, 2/3 of the respondents agreed that the current COVID-19 crisis will accelerate industry transformation. Furthermore, more than 50% report that they've already increased investment in order to adjust to the new future. As digitization becomes more pervasive to address these challenges, there will be 3 trends that we're going to continue to see resonate with customers. The first is the convergence of industries. The second is the use of data. And the third is the emergence of new technologies, all 3 opening the door to transform the way construction gets done. So first, let's look at the convergence of industries. There's no denying that construction firms have begun to adopt manufacturing practices. Architects and builders are looking to manufacturing to make the construction process more like industrial assembly lines, modular, repeatable, and efficient. They're finding ways to use standardized parts and digital tools to improve safety and accelerate project timelines. Now, of course, COVID has increased the interest in building in a more controlled environment. At Autodesk, we call this shift the industrialization of construction and define it as the application of manufacturing techniques to the built environment. This manufacturing approach encompasses prefabrication, panelization, and modular, and includes the creation of any building element in a controlled environment that is then transported to its destination and installed on site. There's no denying that construction firms are on their way to adopting manufacturing practices. Many builders are already employing manufacturing practices and making the construction process more like industrial assembly lines, essentially repeatable and efficient. As you see here, in a US off-site construction facility, Factory OS is industrializing the way low-income multifamily housing is built. The company improves productivity and efficiency by constructing modular units on an assembly line in a controlled environment. Its manufacturing technology allows the company to build high-quality homes 40% faster and at 20% less cost with less waste, all while creating good, stable jobs for local construction workers. Factory OS, their motto is really making housing affordable, not just affordable housing. The convergence of manufacturing and construction will disrupt and transform the construction industry. Some traditional builders have started adopting this concept as well. The next trend I want to highlight is the use of data. Digitizing the job site and automating workflows have delivered tremendous value to construction teams around the world. As project teams use technology to plan and manage projects, vast amounts of project information are created in the forms of documents, models, images, and even video. The data holds a wealth of insight, but only if you're able to access it. According to FMI, 95% of data captured in the construction and engineering industry goes unused. This is where machine learning comes in. Oftentimes you hear about machine learning primarily regarding risk analysis, but that's just one way to apply that technology. More recently at Autodesk, we've been working on process automation, which reduces that manual work associated with data extraction. Recently, we acquired a company called Pipe, which uses machine learning to analyze and extract critical construction data from project plans, submittals, and specifications. This gives construction project teams a full understanding of their project from day one, eliminating communication gaps between teams and ensuring a higher level of quality assurance, efficiency, and risk management across the projects. We're using this technology in other ways too, like symbol detection, which identifies specific symbols across documents, and automated photo tagging, which classifies and structures your photo data. All this gives project teams the power to convert real-time data into actionable insights. The final trend I want to highlight, and one you'll hear much more about today, is the emergence of new technologies in traditional construction practices. Robotics, AR, VR, drone technology, and additive manufacturing or large-scale 3D printing are also gaining momentum in construction as more and more companies seek out innovative ways to address industry challenges to ensure greater job safety, more predictability, and increasing the quality control. So check out this video from one of our strategic customers based in Japan, Shimizu. Shimizu is actively developing and deploying robots on the job site. The robots carry materials such as sheetrock, install panels, and even weld on site. Now, the way they go about this is their robots work at night and place the materials in the right locations for workers, but also for other robots to then install. Today, they use a BIM model for geolocation, and they use AI to maneuver throughout the building. And the precision is incredible. So Shimizu is certainly a market leader and expect to hear more from them. Today, the speed of change requires us to examine business practices more frequently than ever. Understanding where the market is going, keeping up with disruptors, and knowing what the future holds is required for both short and long-term success. This has all of us, technology providers and builders, constantly rethinking and reinventing the way we work. At Autodesk, Our mission is to help construction teams meet the world's rapidly expanding building and infrastructure needs while making construction more predictable, safe, and sustainable. We're focusing on continuous improvement, and we're partnering with customers to help them meet their innovation and digitization priorities, whether they're just starting to go paperless, moving from 2D to 3D, or using AI and generative design tools to optimize workflows. Our solution to help construction teams digitize, integrate, and optimize their processes is the Autodesk Construction Cloud. The breadth of our portfolio, the depth of the capabilities, and the connections that bring together meaningful workflows, that's essentially what Autodesk Construction Cloud is. Construction firms and technology providers around the world are making innovative advances in how the work gets done every day. Today, I highlighted just 3 key trends: offsite construction, data, and robotics that are transforming the construction industry. Personally, I think this is one of the most exciting times in my career. The pace of change within the industry is accelerating so quickly, and the advancements really are truly inspiring. Autodesk is certainly looking forward to continuing our partnership with MassRobotics and partnering with the industry as we redefine the future of construction. So thank you very much.
Thank you, Jim. This is a very insightful presentation, and we also have the pleasure to host a few of the construction companies in the area to give us their first-hand view of the challenges they see on their site. So first up, I would like to introduce Jay Connolly. He's the president of the Connolly brothers, and I had the pleasure to actually visit the company and meet the team. And looking forward for what Jay will be sharing with us.
Good afternoon. Can I change slides here? Or do I? Okay. Good afternoon, everyone. My name is Jay Connolly, president of Connolly Brothers. I want to quickly thank MassRobotics for their invitation to be here today. Really looking forward to hearing more about what you're all working on and how we can help each other moving forward. Today, I'll be discussing what I see as on-site challenges on construction sites, as well as opportunities that may help further the discussion for all of you who are trying to develop your products and ideas. A little bit about us. Connolly Brothers is a 5th-generation construction management firm. We serve the private, commercial, industrial, and institutional markets throughout New England. And our company's been around for 140 years, which a lot of people find hard to believe, but I attribute that to our willingness to adapt through time. And in today's environment, I especially view tech innovation as part of that continuum. So while we're a small company, not necessarily at the leading edge of technology and construction, we can still be part of helping folks like you in the early stages of development, and we can still have a meaningful impact on moving this industry collaboration forward. Quickly on the types of projects we work on, everything from small renovations, additions to ground-up buildings. The ground-up buildings happen to be a little more photogenic here, but on the top left, that's a facility we built for a company called Krona in Beverly, Mass. They manufacture flow metering devices. The second photo in the middle there is a mechanical room on a renovation we did for Rochester Electronics in Newburyport. They manufacture obsolete electronic parts. Top right is a office building reposition called Cityside that we did in Waltham. Bottom left is a building we built for Hi-Res Biosolutions in Beverly. Hi-Res actually manufactures robotic systems that are used in the life science and biotech industries. And the bottom right is a company called Harmonic Drive, and that's in fact how I first met Fady and was introduced to MassRobotics. We met at the ribbon cutting ceremony of Harmonic Drive, which we had finished earlier this year. So Fady and I chatted a little bit and really hit it off, and next thing I knew, I was here touring this beautiful space and walking around, and during my tour, I started noticing the names of companies we've worked for in the past. MITRE Corporation, Analog Devices, Harmonic Drive, and I'm thinking to myself, wow, we've had such a long history with so many of these companies. How can we get involved as a small company and help out? And that's what we're doing. So quickly touching on the types of robotics I see right now, obviously, we've heard Jim talk about it. The robotics are heavily involved in the pre-manufacturing of parts and pieces and products that go into all of our projects. But that's off-site. So on-site, really, we're limited to seeing the use of drones for inspections, both in the air and on the ground. And primarily, we're seeing the use of robotic total stations for surveying and layout uses on-site. So let's talk a little bit about some challenges. So I'm assuming a lot of what I'm saying here, next slide, it has everything to do with why automation and robotics have struggled to break into this industry. But as a for instance, here's two completely different scenarios on projects we worked on in the last year. The photo on the left is a historic restoration of a building that's got a very ornate eave detail, and the photo on the right is recently erected structural steel. So how could a drone that's trying to perform tasks at height be set up to fly up to either one of these situations and make a connection? It's a different setup. It's a major challenge. Not to mention the picture on the right happened to be during the snowstorm we had a few weeks ago. So that presents another challenge, which we'll get into. Next slide. So here's a couple of photos, if you can see them. The photo on the left, I think about how an autonomous vehicle is going to traverse across that site as we're prepping to put a slab in with conduit, rebar, trenches, footings, everything in the way, and this is changing all the time. So that being said, that's a scenario on almost every ground up project that ever happens. There's always going to be a slab that gets placed, and there's always going to be underground utilities that get in there. So, and then the next step in that on the right, you see the actual placement of the concrete, very heavy labor intensive process, but how do you break into that market where it's really, you look at the guy standing up to his knees in concrete, that's not an easy task to wrap your head around how a robot can get in and help out there. So more on challenges. Construction sites are, they're not a controlled environment. So how do you get a drone to fly when it's too windy or snowing? Or how does a battery system work in a particular device if it's too cold out? So weather's a factor. But what works in a lab or a controlled environment that we see behind us be trained or developed to work in varying elements in the field? We also see a lack of standardization. Every site is different, not just by a little bit, they're drastically different. Tenant fit out presents completely different conditions than, say, a ground up building. And that same building built in a different geographic region is going to present a whole nother different set of challenges. So if I'm going to believe in robotics being successful in construction, I need to believe in the ability for them to adapt, be nimble to the different site conditions and scenarios. So in construction, we break a project down into divisions. So all the parts and pieces that break up a complete project, site work, concrete, steel, drywall, plumbing, electrical, and many others. Can you do the same thing as you're working on your product and analyze the smaller parts and pieces of the project and find areas where you can, on a small scale, improve the process? So the more you break down the process, the more you're able to find areas that can be standardized. Lastly, a challenge I can't ignore is was talked about earlier, but the perceived threat or skepticism to the modern day construction worker. So I know you've all dealt with this topic before working in robotics, but one thing I'll say from my perspective, and was also mentioned before, is that to me, this really leads into the opportunity that's out there, because we do have a labor problem in this industry. We don't have enough skilled workforce people in this industry. We do not have enough people to get the work done. And automation can alleviate that problem. And ultimately, that's going to have a positive impact on the entire industry. So more on opportunities, safety, efficiency, cost reduction, ease of labor. Robots are already helping prevent accidents in the industry. Heavy equipment is already being automized to operate. They still have operators in them, but they're basically doing the work on their own. In my career, I've witnessed the concrete foundation industry, one of the kind of oldest school industries out there, really make a huge transformation from laying out foundations with old transits, plumb bobs, tape measures, to nowadays where every foundation subcontractor has a fully robotic total station, and one man can handle the layout in the fraction of a time of a foundation that many men would take days to do before. So the opportunities are there and they're happening. But I keep talking about breaking down the generic project into all of its pieces and zeroing in on what seems attainable, and then collaborating with the experts in whichever trade you identify. So how can we help? We can provide opportunities for you to come visit sites. We've been collaborating with Human Dynamics, who you'll hear from later today, and they're using some of our sites to test their drone. We've also had brainstorming sessions with them. We're listening to their ideas. We're helping talk to them about what we think is going to work and what we think isn't going to work. And we're working with setting them up with specific subcontractors who we feel would benefit most from their development and help in that brainstorming process. So I encourage you to align yourselves with those in the industry that will help develop your ideas. And I know that there's a huge barrier to costs to developing these ideas, but the bigger and more sophisticated construction companies and subcontractors are going to continue to stay out at the leading edge of helping move things along in the field and investing in these processes. But the smaller companies are also going to be there and stay involved. And you need to reach out to them and connect with them and build relationships with them in the particular area where you think your idea or your product is going to work. So you don't just need to talk to the Skanskas and the Suffolks of the world, but you need to get in with the smaller companies and really get down in the weeds and establish relationships that can help move your product forward. So thanks again for the opportunity, and I look forward to hearing from the rest of the speakers.
Thank you, Jay, for the great insights. In the same event that Jay mentioned, the ribbon cutting of Harmonic Drive, I had the pleasure to meet Bill Cummings, the founder and chairman of Cummings Properties, and also Dennis Clark, the CEO. And today we have Dan Linscott, the division manager at the Cummings Properties. He will also share us some insights about the industry.
Good afternoon, and thank you very much for inviting me to this event. Cummings Properties began in 1970, where Bill Cummings had a vision for creating places where businesses can grow and prosper, and supporting the organizations that contribute to the community that they're in. In the 50-year time, Bill has grown the portfolio to over 10 million square feet of commercial real estate, both multifamily, residential, industrial, flex, basically covering the entire gambit of facilities that are out there. We're in 11 different cities and towns throughout the northwest of Boston. Next slide, please. One of Bill's big things is giving back to the community. Cummings Foundation, as you see up there, is kind of the pivot point where all of that works from. And we have a program, you see the $20 million grant program, where we give back to all the communities that we do business in. Andover, Beverly, Burlington, Marlborough, Medford, Somerville, Stoneham, Sudbury, Wakefield, Wilmington, and Woburn, where our headquarters is based. Some of the things that I've seen, if you want to go to the next slide, that this is in my previous life before coming to Cummings Properties. This is a shopping premium outlet center in Clarksburg, Maryland. It's about a 400,000 square foot facility. And one of the things that I thought would robotics could help big time on is the welding down of all the metal decking that makes up a floor or the roof of a structure. Every square foot of metal decking typically is welded down at 6-inch on center on all the bar joists that support the decking underneath it. And it is a slow, time-consuming, arduous process where you got an iron worker who's bent over all day, multiple days, stick welding decking down to the joist below it. I have envisioned the ability of a robot on, say, a track machine, track type layout, where that robot could be set up to travel right along the top of the bar joist. If you want to go to the next picture. You see down the bottom right hand, you'll see a welder bent over, right hand corner of the slide. He's bent over, welding down the metal decking right now. If we had a machine that could set itself up on a bar joist and go right along that bar joist, and every 6 inches drop a weld, welding it down through to the joist below and touch up priming the weld spot right behind it, I think that is a good viable opportunity for a robotic situation here. Like I said, the hundreds of thousands of square feet of metal decking that are involved in a building structure, just something like this would be invaluable. Next slide, please. If you look to the right there, you can see where the white stripes, if you will, the light gray stripes, that's all the touch-up primer that goes down after the decking is welded down to the structure below. That too could be part of the same robotic machine, where the front of the machine is doing the welding and behind the machine it's doing the spray touch-up, working along those lines, moving over to the next line, working backwards, and just kind of zigzagging its way across the top of the roof deck, or the floor deck as the case may be. Next slide. What you see here is the slab on grade that's having all the control joints saw cut into it into a grid pattern to mitigate and control the cracking of the slab. As you can see, there's two guys on walk behind machines that are pushing those along predetermined snap chalk lines that are down on the slab that they follow. Another use for a traveling robotic machine that has the saw built into it that could set itself up, align itself on a line, and traverse across the slab by itself from one end to the other, have the distance programmed into it, where to start and stop, and then moving over to the next line, coming back the other direction, and saw cutting its way through and then turning 90 degrees and basically slicing that pattern up into the checkerboard squares, all by robotics, all by GPS or what have you, whatever the layout technologies that are out there. Next slide. This is an expansion to a shopping center up in Toronto. Parking garage to the right hand side. Another thought on that was all the line striping and paint markings that you see in a parking lot or a parking garage or something like that, kind of the similar traversing robot machine where it became a painter and could set itself up, paint all the lines out, all laid out, gridded out without having to manually get out there with a tape measure and snap chalk lines and walk behind it and spray it out and things of that nature is something that I think is doable. Next slide. So here you can see decking advancing on a building. And by the way, all of these shots, these are shots I took from a drone myself. I do a lot of drone photography of basically every construction site that I've done for the past decade. So drones are a game changer in a lot of different things, especially roof inspections and things of that nature. You can put, I can put a drone in a place where you'll never get a helicopter. And so that technology is pretty remarkable. Back to this slide, you can see where we're advancing the metal decking across the roof. 40-foot sheet of decking. I don't know that we're going to have a robot out in the field that can advance the decking. I still see that as a manual labor situation to get it down and spotted, but then the robot could follow behind and do all of the tedious 6-inch on center welding of that product down to the joist below. Next slide. Another situation here where the roofing is now being installed on this building here. And if you look kind of to the left there, you're going to see a row of magnetic rods that are basically sticking up. There's two guys on the left-hand side there. This is what they call an induction welded roof system. It's a TPO roof system that's induction welded to the insulation washers that hold the insulation down to the metal roof deck. And again, a similar traversing track type machine that could pick up the magnetic sensitivity of the washer and do that in induction welding as it traversed along the row of washers underneath the TPO membrane. Next slide. Back to some of the Cummings portfolio, I think one of our challenges we have every spring is washing all the windows of all the glass on all our buildings. And obviously downtown Boston, it's even more of a challenge, and they build special gantries and rolling scaffoldings and whatnot that traverse around a rail system on top of the building to wash the windows and whatnot. We subcontract out, and guys are out there with boom lifts every spring. And it's a long process, and we cover 11 different communities, so we're scattered and splattered all over the place trying to keep our windows clean. If there was a robotic technology there that could be, suspended off the side of the building, and they could go up and down the building, wash the windows, squeegee them down, it would be a big time saver for a lot of folks. We're not the only ones that have glass on our buildings, obviously. So some things of that I see are doable scenarios where some of the technique, like robotic welding, is already well underway in an in-plant manufacturing. To some of the points Jay raised, when you come out on a construction site, you are in a harsh environment. All the extremes. New England has more extremes than any other part in the country right now, or any time for that matter, as far as our weather extremes that we go through. It certainly takes a toll on human beings. I don't know how that would reflect on, those type of temperature stresses, condensation development from temperature swings and whatnot on the robotics, but those are some of the challenges that you will find out in the field here. Never mind just the logistics of traversing a site. But I think a situation like welded metal decking like that, it's a relatively controlled environment at that point, or a controlled situation. The decking's down, you have a flat surface, albeit convoluted, but that's why I was suggesting a track type machine to bridge across that, versus wheels would be up and down in the convolutes of the deck. But those are some of the things that I think that are a real viable and doable scenario to help our labor shortage that is only getting worse every day. With that, I thank you for your time. Appreciate the opportunity.
Thank you, Dan. This was quite interesting. You shared some very interesting application. I hope some of the entrepreneurs on the webinar will pick up on that. Next, we have Michael Zeppieri from Skanska. Skanska is actually, we have been in touch with them for the last few months because they just did an amazing construction across the parking lot from where we are. Mike is the Director of Innovation Services, the lean subject matter expert for the New England region from Skanska. He will provide a paradigmatic perspective, barriers to adoption. So Mike, the floor is yours.
Thank you, Eddie. So first I want to thank, oh, there we go, okay. Now, first I want to thank MassRobotics for inviting Skanska to present at this event. Some great speakers I'm getting to follow, and I think you'll hear what I have to share echoes a lot of what you've already heard. And also a big thanks to Joyce for taking the time to work with us to craft a message that I hope resonates and is useful to all of you. So to kick off, I'm going to start with the video. So Joyce, if you don't mind playing the video. Oh, we can't hear the audio. Okay, next slide. So being a child of the 80s, robots have always had kind of a dystopian theme to them. I could have gone with the cliche Terminator reference, but I figured at this point, most of you have probably exhausted your streaming service movie options. So the movie clip that you just saw was from a little known gem from the 80s called Runaway. Tom Selleck is a police officer that chases down renegade homicidal robots. It's relevant to this presentation because there's actually the climax of the movie actually takes place on a construction job site, so you get to see at least the 80s view of how robots were going to be used in construction. And it also features the bass player from KISS, Gene Simmons. Our marketing team, I had to explain to them who Gene Simmons is, which made me feel really old. But anyway, it features Gene Simmons as the main villain. So if you need something on your movie playlist, totally check out Runaway. About me, I work in the emerging technology function of Skanska. So the legacy of our group is BIM and VDC, but we have since reached out into all technologies that are disrupting the construction industry. So we're looking at drones, data analytics, reality capture, industrialized construction, and robotics. And what's interesting about the robotics conversation is that there's a convergence with those other disruptions. So robotics in and of themselves have a place in our industry, but also the convergence of where they intersect with industrialized construction and some of the other technologies that we've already kind of covered in this session. I think you'll find that there's some real synergies for robotics in construction. Next slide, please. So Skanska is a global company headquartered in Sweden, and we have a footprint in the Nordics, the UK, Eastern Europe, and the United States. And we build for a better society, and care for life is one of our core values. So the theme that I would want to touch on beyond just the pragmatic view of robotics is the safety, care for life, and sustainability applications for robotics, because given our values as a company, those are things that are important to us, and anywhere where robotics can move the needle in any one of those areas, I think would definitely garner our attention. Next slide, please. In terms of our United States footprint, we have a horizontal construction, a vertical construction, and something that's kind of unique to Skanska is a commercial development capability. So we're not just builders, but we're also developers. And with that comes other applications for robotics that a traditional CM or construction company doesn't necessarily have to contend with or even think about. We're in pretty much every metro area across the United States, sizable, just shy of 8,000 employees. And as you can see, a lot of our investments are aligned to our care for life values. Next slide, please. So working with a global firm like CM, not only do we deal with challenges that are unique to the nations that we work in. So as a global company, there are challenges that are unique to the geographies, like what's important or areas of focus for the markets in the Nordics are different than Eastern Europe, or different than the United States. So there's a spectrum of complexity just working with Skanska as a global company, but even within the portfolio of one of the business units, there's a tremendous amount of variability. So we deal with the challenges of doing, I hesitate to call them commoditized, but maybe less complex buildings like a K through 12 building, and then we're doing mega projects like LaGuardia. And in each of those scenarios, there's different applications for robotics. Next slide, please. So before I talk about the applications for robotics, I want to talk a little bit about why robotics really haven't gotten a footing in Skanska up to date. It's interesting. In my role, I get to hear Jim Lynch talk a lot. I get to hear him at Autodesk University, and it's always, he always has these great futurist videos, and you see these videos and you hear him talk, and you get really, really excited about technology, and you come out of these events and you go back to your company and you say, let's go buy some robots and go do all this cool stuff. And then sometimes you hit the reality of present day. So I thought I would talk about some of those barriers, because as a technologist, you can hear it in my voice. I get excited about technology. I want to bring robotics to job sites and do cool things with robots, but there's some practical constraints to our industry that you should be aware of. So first is cost as a barrier to adoption. We as a company, we see the applications for robotics. Jim covered this. Reality capture, 360 photography. The idea that you can have a robot traversing a job site continuously, constantly capturing data of what's happening on that job site. And when you feed that data into a machine learning algorithm, it's going to give you some predictive or prescriptive analytics, insights into what's happening on your job site. The problem with that is, even if we get someone excited about that use case, then we hit them with the cost of the robot. And the immediate reaction is, well, for the cost of that robot, 4 project engineers can do that work. And do we really need to capture the data continuously? Maybe we only do it at certain milestones of the job. So while there's that kind of the aspirational futurist where the industry is going, there's the reality of today, in that there's that immediate knee-jerk response to just the cost of bringing a robot onto a job site. We haven't figured out a way to do that economically, and even some of the upstream and downstream workflows of what the data that robot is capturing aren't mature enough where we would necessarily even benefit from all that data. So as the industry matures, that might change. The second point I want to touch on, though, is this is actually probably a really bad time to be talking about disruption for robotics. And prior to the global pandemic, I probably would have agreed with the notion that we had a labor shortage. I mean, just look across the United States. You couldn't go to a major city without seeing a skyline dotted with cranes. But the world is changing, and we don't know what a post-COVID-19 world looks like as workers have moved to remote. We don't know what the impact is going to be on commercial office space. We're not sure what the impact is going to be on mass transit. We're not sure what it's going to do for airlines. Some of those things we hope will come back, but at least in the near term, worker shortage may not be as much of a problem as it was prior to the pandemic. And I would just, as you go and talk to trades, and something that I don't think technologists think enough about is think about the workers that you're potentially displacing and kind of put yourself in their shoes and understand why they may have a negative response to you coming into their industry or their world, because their immediate response is going to be, well, you're trying to replace me. So when you approach those conversations, do it with the sensitivity of recognizing that you're dealing with an industry that's dealing with some real challenges right now. There are people that have like a lot of sensitivity and concern around things like job security. Just approach those conversations with the sensitivity that they deserve. Which ties right into the idea of disruption to your workforce, and we as a CM, because we don't self-perform the work. At the end of the day, we need to understand what's the return on the investment. So our trades self-perform the work. I think I said in line with our values, we're open to anything that enhances the safety of our job sites, the quality, our ability to deliver to our partners, to our clients, to our shareholders. But there needs to be an ROI, and there's that sticker shock initial, kind of response to the cost of robotics that I think has been a barrier to adoption. So having said that, next slide, please. It doesn't mean that there's not an opportunity for robotics with our industry, and this is where I'm going to echo a lot of what some of the previous speakers spoke about, but I think more aligned to kind of Skanska's values. So if we can go to the next slide, one of the interesting ripple effects of the pandemic is spending more time at home. It's made more time for me to take on some home projects, and I will tell you, doing work in confined spaces like attic or doing above overhead work. I can't tell you the number of times I've dropped things on my head, screwing in a light bulb, or how many times I've gone to bed having to take Advil because my back hurts because I've contorted it into a shape that it's not used to contorting itself into. Well, this is what our construction workers do to their bodies every single day. And I think most people are aware that the opioid crisis in particular has impacted the construction industry. So we would love to see the robotics industry respond to that through exoskeleton solutions or other things that reduces the physical burden on our construction workers. We're not looking to replace them. We're looking to enable them and extend the ability, their expertise and their ability on the job site, but in a way that allows them to come home safely for their families, and perhaps not face some of the physical ailments and things that just go along with our industry. So that's an area when you approach the trades, approach it from a safety perspective, approach it from a quality of life perspective. Ask them what jobs can be done that reduce the physical ailments that their crews are facing, just due to the nature of construction, and you might find some interesting responses. The next slide talks about industrialized construction. I think everyone sees the application of manufacturing robotics for industrialized construction. I mean, our industry is increasingly embracing the idea of building components in a controlled environment and then shipping them and assembling them on site. But I also kind of like the idea of, rather than large industrial robots doing things on job sites or in controlled environments, is could you use swarms of robots, smaller single-purpose robots, to industrialize the job site itself. I mean, there's a certain beauty to the imperfections in a building. I mean, if you walk around Boston, you see all these beautiful brick buildings that are hundreds of years old. The laying of the brick in those buildings are imperfect, but yet there's a beauty to that imperfection. So in construction, there is almost like, I would say, a place for variation. There's a place for imperfection. We don't have the tolerances requirements of, like, say, the aerospace industry, where if a bolt is off by a fraction of an inch, it disrupts the entire structural integrity of the aircraft. I mean, in construction, there's more tolerance, more room to play. But I would love to see robotics that tackle the industrialized problem, but from the job site perspective. And I think the idea of rails is spot on, which goes to the next and my final slide, is build robots that are purposed to the realities of a job site. What we've seen is that, basically what robotics companies will do is they'll displace the existing technology and you'll just stick a robot on it. So you'll take a scissor lift and they'll put a robot at the top of the scissor lift, not recognizing that the scissor lift is part of the problem. I mean, a scissor lift introduces safety implications. They're large, there's line of sight issues. Maybe we don't want the scissor lift on the job site anymore. Maybe the better solution is to create a rail system with hundreds of little robots swarming along these rails, performing tasks. Anything related to overhead work, confined spaces, those are where the opportunities exist. And again, we would welcome you to talk to the trades. But then also, I think there's a convergence of the conversation between a company like Skanska, a company like Autodesk, and the robotics company to talk about the upstream and the downstream workflow. So if we optimize the ability to capture data on a job site, what are the platforms that are then consuming that data? What are the upstream benefits to the CM? So yeah, we can capture this wealth of data, but are the upstream or downstream platforms in place to consume that data? And then are those platforms in and of themselves? So it's almost like a value stream conversation. And I would say approach the job site using the lean manufacturing 8 wastes. Come to a job site and walk with a superintendent and look for the opportunities to reduce waste, their pain points, understand what a day in their life looks like and what you can do to improve their quality of life. So maybe they can go home earlier. Maybe they're not facing as many safety risks, et cetera, et cetera. So, Skanska is certainly open to facilitating some of these conversations. If it's of interest, for any of the attendees today, feel free to reach out to me or any member of our team, and we're happy to continue this discussion. So thank you very much.
Mike, thank you very much for sharing these interesting insights and ideas. And next we have Suffolk Construction. We have been in touch with Suffolk for some time, and they have some interesting activities around innovation. John Fish, the CEO, have been a great supporter of innovation in the area, and he couldn't join us today, but today we have Raj Ghawa. He's an investment associate at Suffolk Construction. He will share with us some of the unique approaches that they have to innovation, and he will also provide insights into their new collab and boost accelerator. Raj?
Thank you, Fadi, and thanks to MassRobotics for having me today, and thanks to all the presenters. It's been a great conversation so far. For those of you who don't know about Suffolk, we're a $4 billion general contractor headquartered in Boston with national presence across the US. We specialize in large concrete complex buildings and dense urban environments. So think high rises, big casinos, hospitals, buildings for universities. What I'm here to talk about today, though, is how we view innovation, our approach there, and sort of as Fadi alluded, our collab program and our corporate venture capital practice as well. So as you can see on this page here, we think of innovation across 4 pillars. Our collabs, which is our team that links our different operational folks on site to technology. Suffolk Technologies, which is our corporate venture capital practice, which is how we invest in companies in the industry that we're very excited about. And then development at Suffolk and R&D at Suffolk, which I'm not going to talk about today, but they are our own internal development efforts. Development at Suffolk is short-term development, so with 1 to 2 year time horizons, and then R&D is 5+ years, where we think about how we quantify risk and how we predict things on site before they happen. But for today, I'm here to talk about the collabs, Suffolk Technologies, and our inaugural Boost program. In terms of the collabs, we have a dedicated team of 7 directors across our major offices: Boston, New York, Miami, Tampa, San Francisco, Los Angeles, and Dallas, where the teams serves a dual job. They have a dedicated space in each of the offices where we have a lot of cutting edge technology, AR, VR, touch screens, other collaboration tools that gives our operational folks sort of a sense of the technologies that are out there that they can use on their sites. The team also actively goes out to the sites, surveys them about the pain points that they have, the technology that they're using, what pain points have sort of unmet solutions, and then what solutions they're actually using. So the team has been tracking over 60 solutions across 101 of our sites, quantifying the impact of these startup solutions, and then measuring what scales and what doesn't, and then for those who scales faster and why. Next page, please. So this operational test bed across the US has given us fairly differentiated insight into technology solutions that really work and stick in the industry. This allowed us to set up a corporate venture capital practice, which is our way to have skin in the game. If we are customers of these solutions, we're piloting them, we're scaling them, and in the process giving them a lot of product feedback. Let's share in the upside for those companies that we're most excited about. We started on our investment journey a year and a half ago now. We've made 7 investments in 7 quarters. And then we have 2 more logos that we'll hopefully be able to add to this page by the end of the year. I'm not going to tell you too much about those companies, but the point I want to drive home is we have invested across stages, seed through Series C, pre-revenue through hundreds of millions of dollars in revenue. And we found our sweet spot to be in that Series A, Series B range. There's a mature product. You can probably test it on multiple sites, and then we can come in and help the team scale it to the next level. We noticed that there is a little bit of a gap earlier, so say pre-seed through Series A in the industry, where a lot of founders are working on very exciting ideas, but they often have 1 or 2 big challenges that prevent them from getting to that value inflection point. Next page, please. So we came up with the idea of Boost. It is our first time doing it this year. It is a mini accelerator. We sent out a call for applications. We asked founders in the industry to come to us with their most pressing issue, and we promised to pair them with 1 or more of our operational senior leaders to work with them over the course of a month to solve that problem. The idea there is to flip the idea of an accelerator on its head. It's all virtual. It's just 1 month. It is extremely tailored to each startup's need, where we will mostly be working with them on that one specific problem that they've sort of applied to us, asking us to work with them to solve. Next page, please. So in our first time doing this, we sent out a big call for applications. We were able to reach about 1.5 million viewers worldwide. We received 88 applications from 15 countries and 14 states here in the US. We then worked with our partners in the program, the MIT Center for Real Estate, Romulus Capital, Equipment Share, and Bancap Ventures, select 5 finalists who kicked off the program with us just this past Friday. Next page, please. The finalists all happen to be from the US, but they are from all over the country. I'm just going to go through them in alphabetical order real quick, and you'll see how this is relevant to robotics in a second. Canvas uses robotics to automate drywall finishes. Diamond Age uses robotic to 3D print homes in a sort of a factory-like fashion. FlexBase helps subcontractors get paid faster by automating a lot of their financial and payment flows. Passive Logic is, think of it as Nest for HVAC. It helps sort of automate a lot of the HVAC panel functions. And then Thrux is an MEP design and cost estimation tool out of New York. Next page, please. And what we did is we matched these companies with some of our operational leads. For Canvas, we matched them with our general superintendent with 30 years of experience out of San Francisco. He's working with them to see how we can quantify the impact of a robot coming to the site and expediting sort of the timeline to doing drywall finishes. For Diamond Age, we paired them with Dave Fenton, who's our Chief Operating Officer here in Boston, and he's working with them on how to think about setting up that 3D printing sort of construction business. For FlexBase, we paired them up with Rick Wallaga, who's our Director of IT Applications, to help them think through the complex payment flows in the industry. For Passive Logic, it's our Paul Newman, our VP of Corporate Real Estate and Facilities, working with them on how to take their product from the single family home space to more commercial, more complex buildings. And then on Thrux, with Mike Navarro, who's one of our pre-construction managers, who's doing a lot of internal development for us, building our own estimation tools. Taking a bit of a step back, we view a lot of sort of talent coming into the industry. We view a lot of innovation in robotics in particular. I want to echo some of the points made by Mike in particular around the ROI of robotics, and just say that totally agree that while you can do a lot in a factory, it's still not totally clear what robots can do on site. I think the perception of the possible and reality are still a bit far apart. And we hope that through our investment programs, through programs like Boost, we can work with super early stage and young robotics companies and companies across the industry to help them make it to the site and actually scale there very fast. And with that, that's my final page. Thank you very much.
Raj, thank you very much for the insights you shared with us, and congratulations again on launching the mini accelerators. So this will conclude the first half of this event. Now we will have a short break, and then when we'll be back, you will hear from MassRobotics partner Waymo, a Google company, and you will listen about their LiDAR product. And also you will hear from 8 of some of the innovative startups in the space. They're probably doing something that tackles some of the challenges that we heard from the construction companies that presented today. So stick around, and I'll see you in a bit. Thank you. And I just wanted to mention that there is a handout tab in the control panel on the right side of your screen. You can download the file. It will have many of the contacts of the companies that you will be hearing from in the second half. And you can ask them questions directly. As I mentioned, we will not be taking questions real time during the event, but feel free to reach out to those companies and ask them your question. So for the second half, we will kick it off by hearing from one of our partners, Waymo. And I have the pleasure today to welcome Elise Perez. She's the head of LiDAR business at Waymo, and she will be talking to us about the 3D LiDAR for construction applications. Elise?
Great, thank you. Can you all hear me? Hopefully you can hear me. It's hard for me to tell if you can hear me. Can you confirm?
Yes, we can.
Thank you. We're at Google, we use Google Video Conference. So when we have to pivot to a different type of software, it confuses all of us Googlers. Well, thanks for having us today. I'm just going to give you a quick overview of who Waymo is, and then the LiDAR that we use on our fleet of cars today. Cars and trucks, actually. So Waymo means the new way forward in mobility. We're a self-driving technology company with a mission to make it safe and easy for people and things to move around. If you can switch to the next slide, please. Over the last 10 years, we put our technology through the longest and toughest ongoing driving tests. We have self-driven over 20 million miles on public roads. We've driven over 20 billion miles in simulation, and this is all across 25 US cities. In 2009, that's when we started the Google self-driving car project. And at the time, we were considering a product that was similar to L3 driver assist today. So that's, on the freeway from entry ramp to exit ramp. And that is something that we tested with some of our Googlers. And we asked them to be very diligent with the technology and to be very not as trusting, as it was very early days for us. And we found that they were far too trusting. And that experiment caused us to pivot fully to fully self-driving technology, where there's no human intervention involved at all. And so that's what we're focused on today. You probably know in 2015, that's when we did the world's first fully driverless ride on public roads. And in 2016, that's when Waymo was founded. We spun out of Google, and we became Waymo, which we're focused on the world's most experienced driver, the Waymo driver. Next slide, please. Thank you. The Waymo driver, as you see, it applies to a couple of our business lines. Waymo 1 on the left-hand side is to move people around, and Waymo Via is for delivery, moving things around. And on our fleet of cars that we have in multiple cities today, cars and trucks, we use our LiDAR. We use multiple LiDARs. We use multiple LiDARs and cameras and radars, but one of the LiDARs that we use is what we sell today. And so if you hop to the next slide, you can see kind of a close-up shot of our honeycomb. We call it a honeycomb because it looks a little bit like a honeycomb. So this we started to sell in March of last year, March of 2019. As I mentioned, we've been driving, and we still use this LiDAR on our sensor suite today. And we started to sell it outside of Waymo. And it's really exciting because there is so much excitement for our LiDAR, and there's so many other use cases that we didn't know about when we started to sell the LiDAR. There's a lot of interest from construction and agriculture and a lot in warehouse handling as well. And so let me just give you a couple quick highlights of what our customers really are most drawn to about our LiDAR. Next slide, please. 95-degree field of view. So a lot of times other sensors in the market have a much smaller field of view. Well, our LiDAR, which is what we built and we've been using on our fleet for many years, as I mentioned, is what we needed was a much higher vertical field of view. And so if you go to the next slide, you can see a comparison on the left versus the right. You can see the typical field of view of 30 degrees is much smaller. And so a lot versus what we see on the right-hand side is 95 degree. And a lot of our customers have been able to replace multiple LiDARs and instead use one honeycomb, which obviously cuts down on BOM costs. Next slide. Thank you. Our customers also rave about the minimum range of 0. So as you can imagine, if you're working in warehouse and construction environments, you need to have the ability to see right up to 0. And we needed that for our cars as well. And so for our, if you go to the next slide, you can see that we have a minimum range of 0. So my colleague Jack, his hand here goes right up to our honeycomb, and the LiDAR senses it and creates a point cloud right up to the LiDAR. And last but not least, our customers love that we have multiple shots. So thank you, multiple returns per shot. So we have, this is super helpful in dusty environments or where there's a lot of foliage. You can see the point cloud that is created from our LiDAR. You can get up to 3 returns per pulse. And our customers love that because there's a lot of dust that you need to be able to see through, and there's a lot of foliage, and this helps create a much denser point cloud. So with that, if you have any questions, please feel free to contact us at waymo.com/LiDAR. We would love to talk to you about our honeycomb. As I mentioned, there's a lot of customers that are excited about using the Waymo product that we've been using and we still use today on our fleet of cars and trucks. And so we'd love to hear from you.
Please, thank you very much for the presentation, and we're very proud of the partnership we have with Waymo. And now we will hear from several other startups that will share their technology. Next, we have Nextera Robotics. They are doing surveying and prefab. And we have Lana Groff. She's one of MassRobotics residents, and she is the CEO of the company. Lana?
Okay, thank you. So yes, we are Nextera Robotics company. The next slide, please. Company was founded out of MIT. All the founders are MIT alumni with engineering background, and we recently graduated from Y Combinator very successfully. Next slide, please. We are very unique in the robotic landscape in construction. The best part of us, we initially a software company that can operate with any type of hardware. That's what makes us absolutely cost efficient for any type of application we've been working on. We've been around for many years. You know, I have personal experience with robotics for more than 10 years. And the clients that we were serving, they were all over the industries. Next slide, please. So this we put it here for credibility, just to show an example that our software is compatible with any type of hardware. It's not only robotics, but it's the entire hardware stack: lidars, cameras, conveyors, anything that is worked in one single listing because of our software. Next slide, please. So this is the three major solutions that we do at this point. We have Oliver, scan and layout robot, and Nextera Cube as a prefabrication manufacturer that might be located right on the construction site and on site drywall installation. Next slide, please. So Oliver looks like the very simple solution. It is around with many startups. Of course, the biggest value from our side is that we, again, absolutely hardware agnostic. So whatever is available from the battery standpoint, from the efficiency, from the size of a card, from the laser standpoint, the solution is very precise, but it is as cheap or as small or as heavy, as bulky as it's needed for the particular project or for the construction company. This is kind of our core competitive advantage, that we build everything at the absolutely tremendous time. It's very short from the ideation to deployment on site, and also it's a very affordable. Next slide, please. Regarding Oliver, so we are partnering with a few construction companies in Massachusetts on this. I cannot disclose names, but so far everybody was absolutely pleased with the results. This card can do not only 3D model, like very precise laser scanning, next slide please, but also layout. This is kind of a great effort for usually on-site team, right, to do that layout timely, but we make it absolutely smooth transition from digital to field, right, from BIM to field, and our software responsible for the entire hardware piece, and of course for bridging an API for the whatever possible software your engineers or your designers or your architects are using. Next slide, please. This is another product of ours. This is Nextera Cube. Next slide, please. It's not just a 3D model. It's actually will be using on site, right on construction site for the buildings, like you can see on the screen, right? So where you see a lot of frames, it might be with metal studs, with wooden studs, but prefabricated. Next slide, please. For now, it's done all manually. You know better than probably us. Next slide. But in general, how we think about it, it's prefabrication facilities, but right on the site. Next slide. Important part of that, it's very tiny, it's small. It's operated by only one person, and it's very efficient. So when we are thinking about prefabrication, we need to make it cost efficient, it should be high quality, it should be high speed, and it should not, take too many people, out of construction activities. So when you place something like a cube, like Nextera Cube on site, we immediately reduce the delivery costs, like all this, carbon emission thing with the sustainability efforts. At the same time, we have a better on-time product right on the construction site. Next slide, please. Again, so that's just a nice representation, right? So this is the, you can see the white square, right, on the construction site. That's where Nextera Cube will be located. And it might not be only on a wide or large construction site. The height of a cube is not that, and the huge, it's not that high. It might be even done in high rises. So it doesn't matter which construction company is partnering with us. The cube goes inside of all the construction operations. Next slide, please. Another one. So we were partnering on, building this Nextera Cube with Galaxy builders, and they usually operate something like building apartment complex, in Texas, in California area, and we estimate the value of a product like Nextera Cube, and it's a tremendous savings. Next slide, please. It's close to a quarter over budget might be saved if we have a prefabrication facility right on site. And what is good, it's adjustable. It's not only particular site, of course, size, sorry. So it can be almost anything pre-coded, whatever you have in digital. We will adopt it for the factory, right? And it will be in the production cycle very fast. Again, as I said, it might be wood, it might be metal studs, it doesn't matter. The precision, the quality, and on time, that is the key parameters for this product by Nextera. Next slide, please. And another one. So now we are talking about drywall solution. This is very much in development right now. We only have been working on the grippers so far. So, but that's how it will be kind of working all together. We have a few construction kind of robots, of course, in place. Again, just to remind, our core software operates with any type of robotics machinery. So we don't build anything, but we put together the most efficient, the nice solution with the knowledge that we have about robotics. So what robotic arm can do, what cannot, and etc. So that's how it will be looking, you know, and the biggest part here is the gripper. Gripper, of course, we develop ourselves, and then all the rest we are putting together. Important part that we are always working with the domain experts, with the companies. Again, I'm not gonna call names of the companies now, but domain expertise is the most important part for building robust and cost-efficient solution. So again, next slide, please. And another one. Yeah, so what I wanted to say, if you would have any question regarding these solutions or any type of solutions that might be needed, sure, reach out. You know, we will be happy to talk. We are located in Boston. With Zoom, we're located everywhere, and we can show you, you know, like a couple locations that our robots already are. So yeah, thank you very much.
Thank you, Lana. Very interesting presentation. Next, we have Human Dynamics, a drone and inspection manipulation startup. And we have Mike. Mike will be representing today. They are another resident of MassRobotics. Mike.
Thank you. I'm supposed to stand in this box where I'm a little tall. So thank you for having us today. It's an absolute pleasure to be here. We've already learned a lot from our industry speakers earlier, so we appreciate the collaboration opportunity that we've had. So as mentioned, we're Human Dynamics. Next slide, please. We're addressing the global problem of work at heights. So we've already talked about kind of the safety and kind of labor implications that there are in the construction industry, and work at heights is one of the biggest contributors of this problem. You know, I won't go into the details today. I'll try to keep it brief, but next slide. So our vision is applied robotics as a solution. I think that would resonate with the crowd here today to eliminate the personal health and safety risk, making the work faster and cheaper, as well as solving some of the environmental and labor problems. We think there's a lot of relevant markets, but construction to us is the most attractive kind of vertical for us to look at. So let's go to the next slide. The team is a combination of MIT and Harvard. I'm in a dual degree program right now. 3 of us are graduating in May of next year. So we've got engineering and business know-how, and we've also got the world-renowned Dr. Nozaki. He's a robotics professor from Keio University, and he specializes in what's called teleoperation. And I'll talk about that in a few slides. So with this problem and this team, we've come up with our concept, which is on the next slide. We call it Drobot. So Drobot, it's a combination of 3 technologies. It's a commercial off-the-shelf drone. Right now we're baselining a DJI drone. We've got a gripping element that allows us to grab onto a structure such as an I-beam. And then the third piece is what's called the end effector. It's what actually gets the work done. And we're controlling that via teleoperation. So just like some of the conversation we've had earlier today, we're focusing on kind of augmenting the existing skilled labor force, allowing them to stay safely on the ground while Drobot goes up and does light repeatable tasks. So next slide. We've already done an initial proof of concept. You can hit play. Apologies if this is choppy over the webinar, but we've flown it off the ground. We've landed it on an I-beam. We've got this simple gripping element right now. So we grab on to give ourselves some stability, and we actually turn the drone off. So this is important. It gives us longer operation time and gives us stability so we can do higher torque or force operations. Right now, we're just drawing a straight line. This is kind of like our hello world, our first baby step, but that's what we've done so far. Next slide, please. From there, we'll incorporate the teleoperation piece. This is kind of an example from some of Dr. Nozaki's previous work, showing the intuitive control of robotics. We are already talking about how to bring robotics onto the job site. Right now, our current thesis is if we can make it intuitive and kind of easy to use, this will help a lot. Next slide, please. So here's a quick example of, if you have some kind of light exterior facade work to do, instead of using scaffolding, you could use Drobot, saving on costs, saving on time, the number of people required, and then also just how you're getting equipment to and from the job site, flatbed trucks versus, a Mini Cooper, for example. And then also minimizing community impact. So if you're doing stuff in a dense urban environment, less impact to the community. Next slide. And then, as I've alluded to, we love working with the industry partners. Connolly Brothers has been a great help to us so far, as have Suffolk and other folks in the room, and we hope to continue that. So with the next slide, I'll say, please join us in redesigning global infrastructure, and we look forward to working together in the future.
Thank you, Mike. Next, we have Water Tower, water pipe inspection startup. And it's another great resident of MassRobotics. And we have Tyler Mantell, he's the CEO, who will speak about the company.
Awesome. I'm the right height to stand in the box for others playing at home. Yeah, go ahead. Oh, mask off for this. Cool. You get used to the mask. Hopefully, you can hear me better. You can hit the next slide. Yeah, so we're here to talk about water pipes, or really any piping infrastructure. One of the most pressing is water, where we lose 20% of the clean water between the point where it's cleaned, the treatment plant, and the point where it's metered. One of the most important parts of that water we lose is what it does when it comes out of the infrastructure. One, it's really hard to locate and fix, but it creates sinkholes under cities, it destroys buildings, it can eat cars. It's one of the most expensive parts of the water infrastructure, is actually repairing the damage that the water does when it leaves the pipes. And you can go to the next slide, I believe. And one of the big questions, or one of the big difficulties for inspecting water pipes, is how do you get something within the water infrastructure, and how do you identify deteriorated infrastructure in various pipe materials. So some pipes are plastic, some are metal. And that challenge came to MIT. We spun out a year and a half ago now. We rely on our background at Schlumberger inspecting oil and gas pipelines to help with our operational experience. We've done projects around the world, and now we can move on from the obligatory credibility slide and on to what we do. We have a robot that can be inserted into fire hydrants. So being able to use a fire hydrant as a picking station allows us to get a tactile sensor into the pipeline itself. So the robot goes in, it can collapse and get through a lot of the geometry of the fire hydrant. It gets through the fire hydrant and inspects the pipe wall by feeling the wall for a leak. So as it comes across the leak creates a little extra tension on the hands of the robot, which are tactile sensors. Go ahead. When the robot comes out, it creates a three-dimensional map, X, Y, and Z, and plots all of the interesting points along the way. These can be valves that weren't previously known. If you see some of the gray circles on the right side of that map, the orange is a leak that we were able to find at a customer we had. So we're able to create this map for these water entities that don't otherwise have any map of their infrastructure that was put in 120 some years ago. Go ahead and go to the next slide. Yeah, that'll bring us to the end. if we have a second, if anyone has any questions, feel free to ask them. Sweet. Thank you, guys.
Thank you, Tyler. Next, we have Ascend Robotics. They will speak about their painting robot, another great resident of MassRobotics. And we have David Askey, the CEO of the company, will present to us. David?
Thank you, Fady. So Ascend Robotics, again, based in Cambridge, IT alums founded and part of MassRobotics since its founding. So if you can go to the next slide. So our team background has been in solving hard robotics problems for NASA, DARPA, DoD. Just two of the things here. One is a robotic rescue satellite that goes out and attaches to another satellite in space, aging communication satellites. We did all of the arm control for that. So the satellite needs to grasp onto another satellite, grab and extract an aging component, and then swap in a new component. And the other one on the on the right is the world's first fully autonomous oil rig. So it involves 18 different robotic subsystems. The one we're showing here is the largest payload electrically actuated robot in the world. And again, it takes some of the toughest, most dangerous jobs in the world and makes them safe and with predictable quality and much higher production rates. We have a new product line. That's what I want to talk to you about today, is a paint spray system for construction. So our mobile autonomous precision coating system, it's a robot, and I'll show a video of that in just a minute. Mobile robot with an extensible modular arm for reaching in office commercial environments up to 10 feet, extensible up to taking it to 60 plus feet for higher environments. This is for commercial construction. That's for other areas that get painted, which count as, I guess, a mix of construction or manufacturing, such as the ship maintenance, and then another project we're involved with here showing a hospital complex. Just for reference, the paintable area on that ship exceeds the paintable area in the whole hospital complex. Okay, on next. These are the sort of jobs that we're helping folks out with. What's sprayed in say an office environment with latex isn't quite as toxic as this, but this is another area we've been called into for painting more industrial coatings, where the coating we need to provide a very controlled thickness. This tends to be rugged epoxy-like substance. It is not pleasant to be around, and these guys are in hazmat suits. And often these are in warm, hot climates, so it's not a fun job. What we do is the robotics let these guys be safely in a command center on the site, or at least on the floor out of the spray, interacting with the robot, providing enough autonomy to give precision coatings and no runs, no sags. For example, for this example, the rework rate is 40% on these. So again, and then on fighter aircraft, even more critical. If you have runs or sags, that's just not, it's not a good thing for a vehicle like this. So with our approach, we're monitoring, we're doing control, consistent coating thickness, 100% thickness of coverage on the surface, and no run sags ever. Okay, so next. And I will get to a video of the robot in action. We paint about 3 to 4 times faster than a traditional paint crew right now, but we're not about the labor savings, it's more about the consistency of the coating, especially for applications where you need a completeness of coverage, consistent coat, or for construction. If you want to say be in and out of a site overnight instead of taking a whole week to paint, that's where we can come in. The default system, and we painted the entryways and key areas at MassRobotics' new build out. The default system roves around the room, finds the walls, learns for itself what to paint, what not to paint. It gets better as it goes through the site. Designed to paint up to 10 feet high. The total for designed to be extensible, and in recent sites we've gone 60 plus feet high for that. At the same time, we fit through very compact spaces, especially for some of the industrial sites. You only get access through a small porthole or manhole, so the whole system used to go through. This shows just, this is the robot on one of the recent sites. This was actually an apartment complex in central Mass. Our focus is on industrial, but in COVID times, there's still a housing shortage. There's a lot of demand for multi-unit residential. So we went through, this part was just shot in the first apartment. In there, the bot's going through, learning its way through the first couple of rooms. That's showing some of the paint finish. We're doing, this is single coat over drywall so far, and it's already getting better coverage than anything else you'll see. Sorry for the choppiness in the Zoom part, but so here we're showing this. This is slightly sped up. This is by the third room. The bot's just cruising around the room by itself, paints the room in 18 minutes, and that's about the pace we expect once the bot has a sense of, one, whether it should go onto all walls, whether these things that look like windows are windows that should avoid them, whether things on the wall are things that should paint around, like pre-installed fire alarm things, or in this case, new build. It's learned that it can paint over the outlets if it's new construction. So once it asks the operator live, it's feedback that's okay. It just learns and goes on. Okay, next.
We're going to put blue tape over the outlets so it don't get painted.
So blue tape, we built it not to have to count on that, but yes, if you could give it that clue, it would cruise. And then, so we've set it up as a modular system. You can plug in different paint subsystems. So if you've got two-part epoxy, if you've got even spray foam, other things that are a bit more not just to spray, you can clip that in and go. The robot just needs to know what it should paint, what it shouldn't. It's pretty agnostic to what material is just flowing through, and drywall mode for damage. Yeah. Okay, and one last slide. And this is just showing two workspaces. So this is a photo of the lobby here at MassRobotics with the bot painted in a very high-end red, as some of you know, getting a deep color to look perfectly consistent across a whole wall can be an issue. And we recently did a 40-foot high, 100-foot wall, which people tried with a manual approach and couldn't quite get the consistency to look right, so we got called in. And then another painting at the right was at the renovation of a general contractor we work with at their headquarters redid. That's it. Those of you here, stop by and can show you more in person at our office here and answer any questions otherwise. Thanks.
Thank you, Dave. And next we have Vita Inclinata. It's a load stabilization crane. And we have the CEO and VP of Growth, Renee Owen. She's speaking to us from Denver, Colorado. Renee?
Thank you for the warm introduction. Good afternoon. Oh, there we go. Well, technical difficulty to start us off. Well, good afternoon. I'm excited to spend the next 5 minutes with you all talking about active load stabilization. So to kick us off, I want you to imagine completing an entire build on your job site without using a tagline for any of your lists. Can I get my next slide? That's the capability that Vita brings with our load stability system, or our LSS. It's a hardware unit that, using thrust, provides active load stabilization to any loads you have suspended from a cable. It does this providing hands-free, precise rotation, and then mitigating any swing that might be affecting your load or any load sway as you're trying to position it on the job site. We've got a simple hook on the top and the bottom, so it really only adds one step to the installation you'd already be doing. Slide. It works in 3 simple steps. First, our system senses the chaotic motion that would be affecting your load and making it sway or rotate the way you didn't want it to. And then second, we fuse and interpret this data on an onboard computer. And then finally, we use thrust from electric ducted fans to completely counteract any of the swinging and the rotation that your load might have. This keeps the load directly plumb beneath your crane throughout the duration of the lift. Can I get the next slide? So some of the key features we really have with the system is that hands-free control. So we use a remote pennant to allow either the crane operator or your riggers to rotate precisely the load exactly into the position that you want it. This keeps them in the safe lifting zone and eradicates the need to use taglines and have our riggers in dangerous positions. It also can stabilize any of the loads that you're putting on your crane. So it's active and hands-off, constant stabilization of the loads that you have. Slide. So kind of getting into the details here, we can rotate loads up to 66,000 pounds with a lot of variation because our system is modularly built. And then operation times can exceed up to 8 hours. When you're talking about in the field use, with our remote pennant, you can rotate the load 90 degrees in 15 seconds or 180 degrees in 30 seconds. Even with these larger rotations and then the micro movements for putting it into precision place, the pennant allows the rigger or the operator to complete all of these much quicker than we can currently with taglines. Slide. So when you're looking at the benefits beyond reducing the risks of taglines, we really need to quantify this. So what VITA has done is partnered with a company that runs a software called Nixon that actively calculates the risk profiles of job sites depending upon the technology and the tools that you're using. And compared to a tagline that you see here on the left, our system being used to rotate and position the load gives you a 31% risk reduction across the job site. We also make the lifting faster and safer. And with our system using the remote pennant and a couple buttons to orient it, you really don't spend much time on training your team, and the maintenance cycles are pretty long in between as well. Slide. So we're going to see a video here. Oh, perfect, it's running. So in this use case, we were positioning part of a tower crane, and you can see here how the pennant is able to be operated by a remote rigger who doesn't need to use a tagline or try with the precision lifting several times and a couple riggers to get it into place. Our system actually allows you to just spin it directly into place and then drop the load. We'll see real benefits from that precision placement in most operations, but with a highlight on duty cycle loads because you can make them so much more efficient. And then anything where you need to precisely position a load as you're setting it down, our system really excels there. And we'll get into some examples here in a moment. But you can see the operator can stand on the ground, he can stand in the cabin of the crane. Because it's so simple to use, you can really pass it around with the riggers fairly easily. Perfect. So one of the examples that I prepared for you today is steel erection. So with our system being modular in design, we can scale it up and then scale it down for the use case pretty easily. For steel erection, the real benefit people see here is that you don't have any more Christmas train. And that is a problem that's slowly phasing out of the industry, but still prevalent in some cases. And because our system is able to keep the load directly plumbed beneath the crane, you'll not have the movement there of the panels and the steel. So it allows for a much safer and more precise tower crane erection. Slide. We also have precast concrete. So we all know there's a huge issue with kiting in precast concrete, and it's not a great application for taglines due to the size of the loads. But we can use the system here to stabilize any kind of load sway in the rotation. The great thing for this application is that our system is adaptive, and so it can continue providing the stability both rotationally and for the sway if you've got weather coming along. So let's say you're lifting one of these concrete panels up and you suddenly get a 60-mile-an-hour gust of wind. Normally that would be a pretty big risk factor on our job site, but because we're using an engineered solution to solve an error that's coming down, we can eradicate any of the risk there by keeping the load continually plumbed beneath the crane, enabling faster duty cycles and then faster job site completion overall. Slide. The third application I wanted to highlight for you guys today is the modular building. So because you need such precise placement and the pieces are coming together. Using riggers with taglines can be a bit of a difficult obstacle on modular build sites, but our system would allow the rigger to stand away from the modules that you're moving at the moment, and then use the toggle part of the tenant to just rotate them directly into place while standing to the side. So you're not putting riggers in the load path, you're not trying to position and reposition for those precise placements, but you can do that on the first try remotely using the active stabilization. Slide. It's been a real pleasure talking with you all about this and really talking about the future of robotics in construction as the industry is moving in that direction so quickly. Now, my contact information is on the slide here, and it's also in your handout. And I would love to get on the phone or have an email with you about the questions you have about our system or any applications that you'd like to use it in. Thank you.
Renee, thank you very much for the presentation. One thing I was looking forward to hear more about is the meaning of the name of the company, but we can discuss this offline. Next, we have Flex Solutions. It's a snake-like robot for inspection. And we have the founder and the CEO, Matthew Bliski. He's speaking to us from Pennsylvania. Matt?
Thanks for the intro. Yeah, coming here from rainy Pennsylvania. And here at Flex Solutions, when we think about the future of robotics, 5 key areas come to mind. Robots that are customizable, easily commercialized, so able to scale both in production and use. And that really ties into being affordable enough that both large and small scale companies can afford them. Autonomy, both in terms of their capability, but also making it so that users of any skill level can just pick them up and use them. And robots that are miniature enough to get into the places that we can't currently get to enable us to do what we can't currently do. But here at Flex Solutions, we're tired of waiting for the future. So we're just excited to share with you our vision, the FlexBot. Next slide, please. The FlexBot is a snake-like robot, 1 inch in diameter, that costs less than 1/10 of typical robotic systems. Next slide. What makes it so exciting is its modular design. So every link on the FlexBot's identical, and we can easily interchange the ends depending on what we're trying to do. We also have cameras built in, and this allows us to rapidly reconfigure. Next slide. So as I said at the core, every one of our links is identical, so users can combine them, and then the cameras can be stitched together to create realistic 3D, AR, VR, you name it, images. And then end effectors can be swapped out. Next slide, please. So this slide here just kind of shows this concept of you have the one link, which allows for scaling because we only have to perfect this single link, and then people can buy as many as they need to get where they need to get. Next slide. So from a size perspective, 1 inch in diameter really comes from the construction industry, where if you look at codes and standards, you could drill a 1 inch hole in just about anything. And so really making sure that we have a small enough size to be able to fit into these tight cavities that workers find on a regular basis out in the field. And so one of our key advantages is that small size. Next slide, please. So then when we look towards the future of the FlexBot, we really think of this as being an autonomous system that can be deployed in the field, which is really critical during lockdown situations like the one we're facing right now, where the notion is that if they're affordable enough, we could actually pre-install these on mission critical systems. But initially, our goal is to really start with cobotics. Think about what a worker in the field could do with 3 or 4 FlexBot links on the end of a pole or on the end of a fish. Next slide. So really that ties into this notion of affordability. We're using standard components, uniformity, every link being identical, really trying to integrate as tightly as possible and using things like 3D printing to get it so that it's affordable enough to put one of these in every work truck. Next slide, please. And so this notion of affordability and simplicity really is what's going to make it so that we can get to market very quickly. And that also ties in with what technologies we're looking at. Initially, cobotics, working alongside human in the loop, human operator, and then as we learn from the users what they need in user interface and user experiences, start building in autonomy and those capabilities down the road. Next slide. So some examples here of actual functionality that we can swap out the end effector to anything like specialty cameras, drills, grippers, vacuums for cleaning high voltage systems, sprayers for pest control, foam insulation, lubrication, you name it. And then that's combined with, again, every link having a camera in it, which is used both for path planning and also can be used for inspection and mapping and those sort of capabilities. Next slide. So where do we start with all of this? Well, we've been working with the telecom industry to learn about their issues. And something we've been hearing a lot about is problems with underground fiber optic and utility runs, where they have the duct banks and the conduits that they bury underground, but then they go and they find that they can't actually use them. So next slide. So what we're proposing is to be able to actually go into these existing systems, find the blockages, and really trying to either eliminate dig ups, or if you do have to dig up, make it so that it's not guess and check and digging a 50-foot wide trench. It's really pinpointing exactly where the problem is and either solving it or helping you solve it quicker and more inexpensively. Next slide. So at the core of our technology is the ability to expand and rotate all of our links. And that allows us to kind of brace against the walls of a cavity like this and slide forward. So combining our locomotion, which is a problem where they can't actually get the inspection systems there because of all the friction. So combining locomotion with cameras and end effectors can really help us address this problem. But this is just the start, and this is one of the problems we've been learning about from industry. But really excited to be here at this program, hearing more this morning about the problems from the industry partners, and then also hoping to hear back on thoughts of what they would use the FlexBot technology for. Next slide. A little bit about me. I did not go to any Massachusetts universities, but I have a PhD in mechanical engineering and former contractor. So this comes out of my contracting background, and I've really been working to help solve that need of, if I could get there, I know exactly what I would do, but it's just not accessible. And so that's the bridge that we're trying to solve. Next slide. And to help me do that, I'm joined by the rest of the Flex Solutions team who have experience in startups, but also in the construction industry, telecom industry, and robotics that can really help bring this to market. So in closing, thanks again for having us here today. Would love to connect with anybody who has a problem that they think, you know, a steerable endoscope, this notion of affordable snake-like robots that are flexible, adaptable, also known as the FlexBot, could help you solve. Thanks again, and talk to you soon.
Thank you very much for the presentation. And next we have Hyperion Robots. It's a 3D printing company at construction scale. And we have the co-founder and chief design officer, Ashish Mohit. And Ashish is speaking to us from Finland, another testament to the amazing network and outreach that MassRobotics is enjoying. Ashish, the floor is yours. Ashish, we cannot hear you. I think you are muted.
Because it says that I have unmuted. Yeah, okay, sorry. Okay, so I'll start again. Hi, my name is Ashish. I'm an architect since 2007, and I'm a researcher in 3D printing since 2012. And I'm about to finish my PhD in architecture and 3D printing. I'm passionate about how technology influences the way we build, and I'm a co-founder and chief design officer at Hyperion Robotics in Finland. This is a picture which is a testament for what not to do next to the robot. This is a reminder to me. Next slide, please. So as you know that the construction industry is 10% of world's GDP. Everybody knows this. Next slide, please. And it also contributes 11% of the embodied emission. Next slide, please. And everybody also knows the fact that cement is a source of 8% of world's CO2 emissions. Next slide, please. We are building a software engine to automate construction process. Next slide, please. And we are doing this through 3D printing of reinforced concrete. Why 3D printing of reinforcement concrete? Because this is where our experience comes from architecture and construction industry. Next slide, please. What are the benefits of 3D printing technology? 3D printing technology allows us to create projects which could be up to 50% cheaper, 3 times more optimized, 2 times more sustainable, and 5 times more safer. These are the numbers I will go in more detail when I explain about our pilot project and a use case. Next slide, please. Our patent pending technology allows us to load a 3D CAD file, which our proprietary algorithm makes it into a 3D printable file, and our secret sauce and technique of reinforced concrete 3D printing then prints that part. Next, please. Also, when in construction sites, then up to 10 to 15% material goes to waste. With adoption of 3D printing technology, we can bring that almost to no waste. Next, please. This is also 10 times faster. I will again explain these numbers in our use case. Next, please. It's 5 times more safer, as you can see. It's 2 times more sustainable. Next, please. And with use of recycled material, because this is another avenue which the 3D printing technology allows us to use, that we can actually use materials like biochar, mining tailing, fly ash, recycled glass. Next, please. And with combination of these recycled materials and automation, we can create construction projects which could be up to 4 times more sustainable. Next, please. So we are providing product as a service. Right now we are providing hardware, software plus consultancy. But in the future, when most of our clients will have robots, we can provide the technology of automation through our software. Next, please. So this is our use case. So this is one prefab manufacturer based here in Finland. They want to produce an element X. Currently, this element X costs them X amount of euros, and which takes 40 hours of 40 man hours. But with our Hyperion technology of 3D printing concrete together with reinforcement bars, reinforced steel bars, they can bring that cost up to 3 times cheaper, and they can make this 10 times faster, the same element. So this is the use case. We are very popular. We have more than 4 million views on social media. Next, please. Next. And that has generated a lot of interest all around the world. So 3D printing artificial reefs in Australia, to printing 3D printing schools in Central Africa, to building homes for homeless people in North America, and working with prefab companies across Europe. Next, please. We are looking for passionate people who want to produce and construct a sustainable future. You can contact us through our social media and the email which is here. And this is a real-time video of our system 3D printing concrete. Thank you.
Ashish, thank you for the presentation. Just brought to me lots of memories from Finland during my time at Nokia. Next, we have, last but not least, Defy. It's a wearable technology startup, and today we have the CEO and the co-founder, Luke Mooney. He will speak about the company. Luke.
Awesome, thank you. Good afternoon. My name is Luke Mooney. I'm the co-founder CEO of Defy. And next slide, please. We are a wearable technology company based out of Maynard, Massachusetts. And we're most active in the DoD space. That's where we've been developing most of our products for the past 5 years. But it's been really interesting to hear about construction industry today, and there's quite a bit of overlaps. Talking about users who are performing physically difficult tasks in extreme environments with unconstrained movements, and also users who are skeptical of technology. That's something we face every day as well. Next slide, please. So like I said, we're in Maynard, Mass, 10,000 square foot space where we develop, design, and assemble our wearable robotic devices. mostly engineers at this point, but we also do have a micro boot factory, which is pretty neat. Next slide. And so I want to first talk about where the exoskeleton industry has come from. I think it's helpful in understanding where we're headed. For a long time, we tried to build Iron Man. It's the, try to build one tool to do everything that you want to do. Like we learned, that's never really the case. You typically have something that's too heavy, too expensive, too cumbersome, too difficult to use, uncomfortable. And so because of that, you don't see any of these devices in the real world. None of them were commercially successful. But fortunately, we've learned since then, and roughly 5 years ago, took a different approach. Next slide, please. And so we began building devices that were actually specific for what they were going to be used for. And so this is a video of our product, the ExoBoot, and we were targeting mobility. We're developing a device that allows users to walk more efficiently, carry more loads, run faster, jump higher, and overall augment mobility. And so, like many other robotic solutions, we use AI, onboard motors, sensors, adaptive control schemes. But since we are so intimate with our users and actually being worn on the body, we place a very heavy focus on being easy to use and intuitive, and really as simple as strapping on a shin guard plus lacing up your boots. And so, we have focused to this point mostly on the soldier and how do you enable the soldier to more safely carry load. And you want to just jump ahead to the next slide. This has led to the device we have today, which we'll be demonstrating in a few minutes. And it's worn beneath the knee, and it is able to actually offset the load of roughly 50 pounds. So a 100-pound pack feels like a 50-pound pack. But what some of the areas that we're most excited about is how that physiologically affects the users. We're seeing benefits in the ankle joints, the knee joints, the lower back, the hips. So if we are talking about a limited labor force, how do we keep the laborers that we have healthier, longer, and also improve their efficiency and performance at the same time? A lot of the same problems that we're also trying to address with soldiers. And the last slide, please. So, we have focused mostly with soldiers, but we are also exploring things like firefighters, first responders, operations and maintenance. I actually lied, this wasn't the last slide, but the next one is first the last slide. But I also wanted to mention a bunch of different tools that are currently being developed for the construction industry. So none of these are defined products, but unlike the Iron Man approach, these companies have all looked at what are specific needs within the industry and how do we develop a solution that meets those needs. And so for the most part, the industry has targeted either lower back or manipulators in order to allow you to hold tools overhead. Two problems that I heard discussed already today. And these devices are also typically passive. And so because of that, they are cheaper, maybe lightweight. It's still a young industry, but I know that some major corporations have started investing heavily in some of these technologies in order to see how they can help construction workers and laborers. So I would encourage you to check out these companies as well for potential solutions to any of the issues you may have. And that's all I have. I'll be around later and can show off the ExoBoot. You can even give it a try if you'd like. But again, my name's Luke Mooney, and feel free to reach out if you want to talk about Exos. Thanks.
Thank you. So this leads us to the conclusion of our event today. Thank you all for attending this event. Many thanks for the presenters today, both the construction companies and the startups. I also want to acknowledge and thank our team from MassRobotics who did all the heavy lifting today to bring to you this event. Khalif, Mitchell, Joyce Sidopoulos, and Tom Ryden, and also our partners, Autodesk, Yuri, he has done also a great job. For those of you who are not yet on our newsletter, please check our website, massrobotics.org. You can sign up for our newsletter, and you can check our virtual online calendar so that you can get regular updates about what's going on in robotics. Recording for the event today will be sent shortly, hopefully by tomorrow, but don't quote me on that. Next week, for the partners and the investors on the webinar, we will have our biannual invite-only demo day. So if you are a partner or an investor, please make sure to check this event. We will have 16 more innovative startups that will be presenting and demoing actual prototypes. If you don't have the invite, feel free to reach out to us. And also, if you are interested to become a partner, please reach out to us. We'd love to discuss this. As you have seen today, we cannot really scale the next generation of robotics company unless we have large corporates and key players in their vertical segments to partner with us and to partner with our startup. Thank you again for spending this afternoon with us, and have a great rest of the day.